This is my code, how I say. So I'm going to do this by myself. The person I was supposed to do it joined another group, so I was left alone and tried to find someone, but I couldn't. So this is how I import in my library. The best things that I'm going to use is this one and the Pyod library. This is Python outlier detection, as it is self-explanatory. So I'm going just to rush through how my modules. So I use Spark Session. As you can see, I was using Spark to read my CSV file. And then there was feature engineering. I was cleaning my data, removing some of the columns that were not necessary, and removing some of the stuff. This is condemnation. I was using condemnation to create certain rate in terms of how our data is doing it, even the fraud in it. Then this is another interesting part in terms of in the data engineering. As you can see on our data set, we have this column, transaction time. As you can see, even if you encode this column, doesn't make sense and how it's useful it's going to be. So what I did, I factored out and created some functions to develop the day of the week, the day of the year, the week of the year from that column. So this is the column that I was using. This is another interesting part. This is the correlation, just relating how our columns are related to the crowd. So this is the columns that I end up having by removing other columns that I was thinking they are not necessary in determining the fraud. So the label result is just the y, xy. Then label encoder, this is I did some encoding in order to cater for categorical features. So I split my data into XY, in X train, in Y train. Then isolation forest. So there are three things. These things are very important. There's isolation forest. I was using these models to predict the outliers in my data set. So these isolation and the models that I was using, they were coming from Pyod library, which is Python outlier detector. So the isolation forest. So I created another column for outliers, which is called the isolation forest. There was this LSCP, which is local synthetic combination in Python, which was coming from Python outlier detector. So I'm just rushing through since I have 5 minutes. Then there's k-nearest neighbor, which was doing the same thing in terms of detecting the outliers in my dataset. Okay, I go and I rush through, and there was this new feature, count detection. So I was creating another column in my dataset, which is the addition of this isolation forest plus this column for k-nearest neighbor to come up with this count detection. So I'm just rushing through. So this is how I was engineering my data. As you can see, my final data end up giving something like this. This column and this column and this column and this column. This is how my final data set, the X train end up giving something like this. This is interesting in terms of engineering the data set so that we end up with a robust data set. So this is adding all the features to one data set. So here I just did a group by counter detection is I was adding those three columns. So we end up having 0, 1, 2, or 3 in the counter. So it's something like this. We are adding 1, 2, 3 to come up with count detection. This is our final data set. I did again the correlation. Then there's this interesting part that I did in my dataset, balancing. So it was using a small technique. This is a function that is used in statistics for balancing. In statistics, there's a function that is called smart algorithm. Here, this one is called smart technique, which is more advanced than these in statistics. You know, people would call the advanced things. Okay, then I move downwards. So how it balances the data set. So it's trying to balance between the 0 and 1. So our data set, as you can see, is balanced. That is fraudulent, something that is awesome to make our model that is we are going to train to be robust. Okay, then there's K-boost classifier. K-boost classifier is the model that I'm going to use to build my fraud detection model. So I was using K-boost classifier. As you can see, I choose evaluation metric, which is F1 score. I was using GPU devices was 0. Then random seed was 42. This is how we are doing the random. X-motic, this was my X-train, is because I use this small technique to balance my data set. So I just named it X small technique, which is balanced, then the Y technique, which is balanced. So I trained here my model. So after finishing training my model, this is the evaluation of the one output. As you can see, it's the evaluation, which is just nice. As you can see, these are the columns that are involved. And up to the end, I was failing to scroll it up to the end to see the final output from the model. So this one is also summarizes how our columns will producing the fraud from high to low. As you can see, it's from low to high. So count detection was highly involved in detecting the fraud. Then pricing strategy, isolation forest, these things. As you can see, most of these columns I have engineered so that my model will be robust. So that was the most things that I was doing. Evaluation. On evaluation, what I'm doing, I'm just testing my model using the test set that you have given to us. As you can see, I'm uploading it here. Then I will just do some engineering to the test set so that it will fit into the model. So this is after having our final test data set, then I feed it into the model, then I predict it. So how I was when I was predicting it, it's like I was saving it to a text file since the test set is a large file. So I was saving the results in the database. Sounds interesting. Not the database, I was saving it in my drive. I will show you the output after. So I've saved the prediction here. So it's something like this. This is the predictions text file. Okay. So from the prediction text file, there is two options, which is 0 and 1. So this is the result. I'll do control find. From this, I'll do control find. This is the result for 0. The first column, this is the transaction I did. And if I do 1, this is the output. As you can see, there are about 390 results from where there is fraud. So basically, that is the whole my model. And some of the challenges that I faced is like I had to encode some of categorical features to make them zeros and ones. This was another challenge, and there was some unique challenges that I faced in order to engineer my dataset so that it will make our model the best by, for example, what I did here on this column, factoring out, calculating the year, the date, the day of the week from these only columns. That's with some of the challenges so that our data set at the end will be the best data set. And I did some of the things engineering using the isolation method, using the k-nearest, using the LSP to calculate and come up with some of the columns that were not in the dataset so that our dataset will be the best. So I end up coming with 4 new columns, which is using these methods that I was there in the Payot library. So this is some of the engineering that I did, some of the challenges that I faced in preparing my dataset and coming up with the evaluation method. I end up coming with F1 score in terms of evaluating my model whilst I was training it.